Okay, here's your 4.7 warm-up. So go ahead and take out your warm-ups, work on these two problems. I apologize for having to be gone again today. My oldest had a fever the middle of the night, and so mom gets to stay home with him. So again, I apologize. The test is still going to be Monday. You've had video notes, business as usual. You could always look back at section 4.7, listen back to this on Brightspace, because that's where all these videos are posted and all the answer keys and that kind of stuff. So go ahead and pause this and work on these problems. Okay, so this is using the two theorems that you guys learned yesterday. So the first one was called the base angles theorem. And so we have an isosceles triangle here, and you've got two congruent sides. And so the isosceles base angles theorem says that if you look at the angles across from those two congruent sides, they are congruent to each other. So the angle across from this side is this angle right here, and the angle across from this side is this angle over here. So then I'm going to mark those two angles congruent. So to find x, I know that this is going to be the same, so this will be 52 degrees. So I add those up and I get 104, and then since we know that the three angles in a triangle add up to 180, you do 180 minus the 104, and so you should get x equals 76. So that one you don't have to show a lot of work on, but I'm going to ask you that you mark your picture so that you know which angles will be congruent to each other. Okay. On number 2, they only give you two angles and not the third. Please, please do not add up, because 2x plus 5 means it's this side length, 21 is this side length, and x plus 12 is this side length. You do not add up three sides of a triangle and set it equal to 180 degrees, because sides do not add up to equal a degree. Okay, sides are inches and feet and units, that kind of stuff, but not degrees. So what we need to do is first decide if it's equilateral. If it is, great, all three of these sides are the same. If not, maybe it's isosceles, only two sides will be the same. So in order to figure that out, I have to figure out this missing angle. So again, we know that the three angles inside a triangle will add up to 180 degrees. So you add the 28 and the 76 and you get 104. And so then subtract that from 180, that means this angle should be 76 degrees. So then knowing the converse of the isosceles base angles theorem says that if you've got two congruent angles, so this angle is congruent to this angle, then the sides opposite those angles will be congruent to each other. So the side opposite this angle is this one, so I'm going to put a slash on it. And the side opposite from this angle is this one, so I'm going to put a slash on that. So then I know these two sides are the same. This is extra information that I'm not going to use in my equation. So then if I know these are congruent, I would set these equal to each other. So 2x plus 5 equals x plus 12, and then we'll solve for x. So I'm going to minus x over, so that'll give me x plus 5 equals 12. Subtract 5. X is going to be 7. And that's all they wanted, was for you to find the value of x. Okay. Now what I'm going to do is I'm going to go over, you had some book problems to work on, and so I'm going to do a few of those that I thought maybe you might have questions on. So go ahead and get out your homework if you don't have it out already. Okay, so the first two problems I want to go over, excuse me, are numbers 3 and 5 that you had. And so this is the picture that goes with it. So number 3 says that if segment AE is congruent to segment DE, then blank angle is congruent to another angle. And so that means we're looking at this big isosceles triangle here. So then which angles should be congruent to each other? It's going to be the angles across from each of these sides. So in this big triangle, that would be the angle across from this side is angle A. And that's going to be congruent to the angle opposite this side, which would be angle D. Okay, so we're looking at this big isosceles triangle. So the angles across from each of these sides is angle A and angle D. Then on number 5, let me erase these marks. And so then on number 5, it says angle D is congruent to angle CED. Remember when they give you 3 letters, you always mark it at the middle letter. So if I look at angle E, it's got 3 different angles there. So those other 2 letters tell me which of these 3 it is. So since it says CED, it's this angle right here at E. So it's always at the middle letter. And then if there's multiple angles at that middle letter, the other 2 letters that were in front of it and behind that let you know which angle it is. Okay, so we are now looking at this triangle, triangle CED. And so I know these 2 angles are congruent. So by the converse of the base angles theorem, it says that the sides opposite those are going to be congruent. So the side opposite this is this side, and the side opposite this angle is this side. So then I would say segment CE, or you could have flipped that around, is congruent to segment CD. Okay. All right, number 16 is another one I want to talk about. So we have an isosceles triangle. And so you've got 2 variables, an x and a y. So I don't want to add this plus this equals 180 right now, because then I'll have just one equation with 2 variables in it, which I cannot solve. So I'm just going to use one of the theorems. So I know these 2 sides are congruent. So then that means I know this angle across from this side and this angle across from this side are going to be congruent to each other. So congruent means I'll set them equal to each other to solve. Okay. And so then I would minus 7. So then x will equal 48. And the directions just asked you to solve for the variables. So I know x is 48, so that means that this angle will come out to be 55 degrees, just like this angle. Now I can do triangle sum theorem that says if I add up all the angles in a triangle, they add up to 180. So I would do y plus 55 is 110 equals 180. And so then minus that, so y has to be 70. So there's your 2 variables. So you just use the base angles theorem on that. Okay, the next one I wanted to talk about was number 17, and you can pause as you need to or rewind if I'm going too fast. You can always pause. And on this one, so we have an isosceles right triangle because we see the right angle here. Again, use these sides. So knowing that these sides are congruent, we know that the angles opposite them are congruent, so that angle is congruent to that angle. Okay. Now, I don't want to set x equal to 9y because then I have 2 variables and I can't solve for one. So then we have to use this 90-degree angle. So then I would do 180 minus 90, which gives me 90. So I know these 2 angles here have to add up to be 90. Well, I also know that they have to be congruent to each other. So if I do 90 divided by 2, that means each of those angles has to be 45 degrees. So this is 45 degrees, and this is 45 degrees. So now I can use that to find my variables. So then I know x is going to be 45. And then if I set 9y equal to 45, because that angle has to be 45, and I divide, that means y is going to be 5. Okay? So I couldn't set these equal to each other and say x equals 9y and solve, but I used this 90, subtracted that from 180, and said these 2 angles have to add up to be 90, and they also are congruent, so then they're each 45 degrees. And then I set up accordingly. The last one I want to talk about is number 20. And so on this one, you got a lot going on, and you may not know where to start. I would always start with the triangle where they actually give you an angle measure, not like with y's and x's and all that stuff, but they give you a specific number. So this angle is 50. And this is a vertex angle, remember, because that's where the 2 congruent sides meet. So they give you the vertex angle, they tell you this is something here, and then we also know that this angle is over here. So I'm going to start in this triangle. So again, I know that these congruent sides mean that the angles opposite them. So this angle, whoop, crazy pen marking some stuff on its own again. So that means that the angle opposite this side is congruent to the angle opposite this side, which is right here. So I know these two angles have to come out to be the same. So then I'm just going to do some math. I'm going to do 180 minus 50, which is 130. So I know these two angles have to add up to 130. I also know they're the same, so then I'm going to do 130 divided by 2, which is 65. So then I know this angle is 65 degrees and this angle is 65 degrees. So then I'm going to set my equation 2y plus 64 equal to 65. So now solve. Minus 64, 2y equals 1, divide by 2, so y is 1/2. Okay? Now I'm going to work my way this way. So I'm going to do a little math and come up with this vertex angle, because you have an isosceles triangle here where these two congruent sides meet is this vertex angle right here. So then I'll do 180 minus 65, which is, what, 115? So this angle is 115 degrees. Okay? So now I'm going to do the same thing I did over here, where I'm going to, since these two sides are congruent, I know that this angle is congruent to this angle, and I'm putting double arcs because I don't know that they're congruent to the 65 or not that I had marked previously. And so then even though these sides, all these three sides were the same, it doesn't mean that all four of these base angles are going to be the same. So then I'm going to do 180 minus 115, right? Yeah. Which that's going to be that 65. And so then I'm going to take 65 and cut it in half, because 65 has to be these two angles together. And so that comes out to be 32.5. So that means each of these angles are 32.5 degrees. So then that tells me what I'm going to set this equal to. So 45 minus x divided by 4 equals 32.5. Okay, now I'm going to solve, so I'm going to subtract 45. And that's a minus sign in front, so that'll be negative x over 4. Or you could put the negative with the 4, which is what I'm going to do. And then when you do 32.5 minus 45, you get negative 12.5. Now this says x divided by negative 4, so then what's the opposite of division? That's right, we multiply by negative 4 on both sides. So I'm left with x over here, and then you get negative 12.5 times negative 4 is 50. So that's your x. Okay? Alright, so that concludes this video over homework and the warm-up. So now close everything up and just have a pencil and a calculator out so that you can take your 4.7 quiz.